Module 8.2, Fundamental Identities and the Difference in Sum Identities. Section 7.1 and 7.3 in your book. 8.2 opener. In this section, we're going to continue our study of trig identities that make calculations easier. You should already know the Pythagorean identity and the sum. You should already know the Pythagorean identity, and you're going to have the sum and the difference identity memorized as well. And again, notice that the Pythagorean identity is very similar to the Pythagorean theorem. One more important thing is you're going to have to definitely memorize the sum and different identities. There's so many identities, but these are the most important ones. From these identities, you can find a lot of the other ones. Alright, so some of the fundamental identities. The Pythagorean identity, for example, is very fundamental. 1 is equal to cosine x squared plus sine of x squared. Right, there is one for secant also, one that had secant and tangent, and the one that had cosecant and cotangent. Can you remember the other two? We've already gone over it. We also had the reciprocal identities. Remember, that was that cosecant of x is equal to 1 over sine of x. And there were two more, one for secant x and one for cotangent of x. Can you remember the other two? Another important fundamental identity was the even and odd identities. Even and odd. Remember that sine of negative x, is equal to negative sine of x. There was one for cosine of negative x, and there was one for tangent of negative x also. Can you remember the next two? You should know them. If not, you should absolutely make sure you know them now. Alright, and we're going to look at some examples here that we've done before, actually. We have theta in quadrant 2. Right? And we need to find cosine theta if we know that sine theta is 2 over 3. So what is cosine theta? Really, the whole point is, what is x down here? Well, you can use Pythagorean theorem. 9 minus 4, right? 3 squared minus 2 squared should equal x squared. So this is 5 should equal x squared, or the square root of 5 should equal x. And we're going to use negative square root of 5 because x is in the second quadrant. So we have cosine theta is negative square root of 5 over 3. If tangent theta is equal to negative 5/3, find secant theta if theta is in quadrant 2. And we can do this the same way. We can build the triangle and see what we get. What's another way of doing this? Another way of doing this is using those fundamental identities. So we're going to use the one for secant theta and tangent theta. That was the one that said tangent theta squared plus 1 is equal to secant theta squared. That's one way of memorizing it. So tangent theta squared would be negative 5 over 3 squared plus 1 is equal to secant theta squared. This is 25 over 9 plus 1, but instead of 1 we're going to write 9 over 9 is equal to secant theta. And to get rid of the square root, or square, we're going to take the square root. We're in quadrant 2, so what do we know about secant there? Well, we know that cosine is negative, is less than 0, or negative. And because secant is just 1 over cosine, we also know that secant is negative also. They're the same value, just reciprocals. So secant theta will equal 25 plus 9, which is 36 square roots over 9, or 6 over 3, or 2. And again, secant theta should be negative. So negative, 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 negative. Sum and difference identities. For angles A and B, we have that cosine of A plus B is equal to cosine of A cosine of B minus sine A sine B. These look very complicated to memorize. So remember that we're just doing sums and differences. We're adding here, and we're trying to make it into times over here. The way that I remember it is think cosine of, adding, because that's the important identity, is cosine cosine minus sine sine. So it's the other way. If we're adding here, we're subtracting there. And likewise, if we're subtracting here, we're going to add there. We do the opposite. And everything else stays the same. Cosine of A minus B is cosine of A cosine of B plus sine of A sine of B. Cosine cosine of different angles plus sine sine of the different angles. A shorthand way of writing both of those is to use the plus or minus symbol. Cosine of A plus or minus B is equal to cosine of A cosine of B minus plus sine of A sine of B. In other words, this plus goes with that minus. This minus goes with that plus. Also, there's a similar identity for sine. But instead of cosine cosine, we get sine cosine, sine cosine. And we still use both the angles. Here we used A and B, A and B, A, B, A, B, A, B, A, B. Right? The only thing we're switching around is instead of cosine cosine, sine sine, now we're doing one of each. Sine cosine, sine cosine. Right? Sine of A here, cosine of A there. Cosine of B there, sine of B there. And notice that this plus stays with the plus this time. If we're adding with sine, then we're adding on the other side. Here, if we're subtracting, then we're subtracting. Okay. So let's look at an example. The more you practice this, the easier it'll get. Cosine of 15. Instead of 15, I want to, because this is not one I should have memorized, right? I'm going to use 45 minus 30. Why do I want to use 45 and 30? Because I know those values. I know cosine 45, cosine 30, sine 45, sine 30. So remember, it says minus here, so for cosine we're going to have a plus. And it's cosine, cosine, sine, sine. And now we're just going to put those values there. 45, 30, 45, 30. Cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Sine of 45 is square root of 2 over 2. Sine of 30 is 1/2. This is square root of 6 over 4 plus square root of 2 over 4, or square root of 6 plus square root of 2 over 4. The cofunction identities. We've already gone over these. Sine and cosine are cofunctions. And that means that whatever's in here is just complementary angles. So but now we're just going to make sure we still know this and we can work with radians. So write sine of 7 pi over 24 in terms of its cofunction. So that should equal cosine, right? We're using this one right here, by the way. Sine of A, or sine of 7 pi over 24 should equal cosine of 90, but we're in radians, so it's pi over 2 minus 7 pi over 24. You should be comfortable working with fractions. Instead of 2, we need a 24 there, so we need to multiply it by 12. This is 12 pi minus 7 pi over 24. Or cosine of, what is that, 5 pi over 24. And we're done. This example is a little bit more complicated, but try it on your own. Maybe try it for a good 10 minutes. Okay, so we have that cosine is 3/5 and sine of t is cosine of s, it's important here, is 3/5 and sine of t, a different angle, these are different angles now, is -1/5. And they're both in quadrant 4. So maybe we have a triangle like that. Maybe we have another triangle like this. We don't know, but we know that both those angles, S and T, are in quadrant 4. We're going to find cosine of S plus T. So the plus is going to tell us to use this sum identity for cosine, because we don't know any of the other values. So we're going to use cosine of S plus T, which is equal to, remember, cosine of S, cosine of T minus sine S, sine T. We already know, so we know cosine of S plus T is what we're trying to find. We were given cosine of S is 3/5. So here we're just going to write 3/5. We're not given cosine T anywhere. Minus sine of S. We're not given sine S. But we know sine T is equal to -1/5. So this should be plus 1/5 because of that negative sign. And all we have to do is find cosine T. So to find cosine T, we're going to take sine T. Sine T is -1/5 to find cosine T. So again, we're in the fourth quadrant. Sine T is -1/5. So 5 squared, which is 25, minus 1 squared, which is 1. 25 minus 1 is 24. We're using Pythagorean theorem here. We're trying to find this angle, x. So we have x squared plus -1 squared is equal to 5 squared. Or x is equal to 5 squared minus 1. 25 minus 1 square roots, or the square root of 24, is this x value. So that tells us that cosine of t is square root of 24 over the adjacent over the hypotenuse, 5. Likewise, to find sine s, we need to use cosine s. Still in the fourth quadrant, cosine s is the adjacent over the hypotenuse. So again, we're going to do 25 minus 9 square roots. 25 minus 9 is 16. 16 square roots is 4. So this is 4. And this is, and sine of s is 4 over 5. Times 1/5. So this is 3 square roots of 24 plus 4 over 25. And you can simplify this one more step. Right? I'm not going to write down the steps, but you should try to figure it out on your own. 6 square roots of 6 plus 4 over 25. You're now ready to start homework section 8.2.